Good afternoon. My name is Charles Scott from Civil Designer Software. Thank you very much for allowing the time to join us today. I trust everyone is safe and well. Welcome to this month's Open Classroom webinar, our 66th in the Civil Designer Software Open Classroom webinar series. This series forms part of our greater suite of support services created to assist you, our existing clients, as well as all our new clients with the efficient application of this design, analysis, and documentation software resource. Please visit our website's services section for a full list of the services unique to Civil Designer. And in the webinar section, please find a list of our past webinars facilitated by Andrew Cole, Cameron Boyle and Christopher Smith since the beginning of April last year. Please also visit our FAQ page, which now hosts 340 short, searchable videos created from our past webinars. Videos covering topics such as our BIM data files workflow interoperability, dealing with GIS data, and how to best utilize our help desk support services. Finally, please visit our client showcase section for more information on where your industry colleagues are taking Civil Designer to. Back to today's webinar, where we welcome back Christopher Smith, who many of you will know well from our support center, as well as the many training courses he has facilitated over the years. During Chris's time today, please do not hesitate to send us any questions you may have using the text question messenger service in the GoToWebinar app. Please remember, we will be posting a recording of today's meeting in our website's webinar section later this afternoon. So, good afternoon again, Chris, and please take it away.
Thanks, Charles, and welcome everybody to this edition where today we're going to be looking at fire hydrants. We'll be exploring it in a little bit of detail and see how best to go about creating the fire hydrants and how best to analyze the results that you're going to receive. Let's jump straight into it and go over to our categories for the fire hydrants. So that will be under Tools, Catalogs, Fire Risk Categories. Here you can see we've shipped the software with 5 categories. You'll see here that we have the high risk, for example, that requires a minimum free flow of 12,000 liters per minute. We also have the minimum flow per hydrant during an event of 1,500 liters per minute. During the fire flow analysis, each hydrant will be processed individually. During a hydrant which is a high risk, all hydrants within a radius of 270 meters will be switched on at the same time. This is to calculate the flow requirement for all of these hydrants to be switched on. The required residual head at each hydrant for the high risk will be 15 meters. The placement of each hydrant will be 120 meters apart, and the fire flow duration will be 6 hours for the high risk. So each one will have different values put in there, and if we just go over the different categories, we've got the high risk. These are areas of risk where the fire and the spread of fire is high, such as congested industrial areas, congested commercial areas, warehouse districts, central business districts, and general residential with a floor space ratio of 1 and greater, where buildings are 4 stories and more in height. We have then the moderate risk areas. These are areas of risk of fire and the spread of fire is moderate, such as industrial areas or areas zoned as general residential with a floor space ratio less than 1, and where buildings are not more than 3 stories in height. Commercial areas normally occur in residential districts where buildings are not more than 3 stories in height. We then have the 3 categories of the low risk. The first is the low risk areas. These are areas in which the risk of fire and the spread of fire is low. The categories are subdivided into 4 groups. We have the low risk group 1. Residential areas. These are where the gross floor area of the dwelling house, including the outbuildings, is generally likely to be more than 200 square meters. We have the low risk group 2. These are residential areas where the gross floor area of the dwelling, including the outbuildings, is likely to be varied between 100 squares and 200 square meters. We then have the low risk group 3. These are residential areas where the gross floor area of the dwelling, including the outbuildings, is generally likely to be less than 55 square meters, but not more than 100 square meters. This group includes low-cost housing schemes where the gross floor area of the dwelling, including the outbuildings, and allowing for extensions by the owner, would generally not exceed 100 square meters. Restrictions in force control the height and the area of the building materials used in the construction and the distance from the common earth boundaries. Attached dwellings units are separated by a firewall with a minimum fire resistance rating of 1 hour. Should any of these categories not be suitable for your local municipality, you're always welcome to use the Add button and fill in all the details required to have your own fire risk categories. Before we close this dialogue, I just wanted us to take note that we'll be dealing with liters per minute for the flow rates in this WebEx. The first part of running your fire flow analysis is to actually look at a completely other part of the project, and that is to look at the reticulation itself. Is it in order? Are you happy with it? Look, there might be changes with your reservoir capacities after you've run the analysis, or maybe you have got an existing network and you're going to have to build a new reservoir to make changes for perhaps your town's got new specs for firefighting. The first point is to run a analysis on your water network. So we'll just make sure we're in water mode still, and we're going to go to analyze, and we're going to run a time simulation. So we'll do that over 24 hours with increments of every 15 minutes. I'll then press start and check for messages to see if there's any issues on the water network. With no errors, we can close this. With that analyzed now, let's go in and zoom into our reservoir. You can see I've got my reservoir over here. If I select it, we can go and look at the graph over 24 hours. Remember, when it comes to water, the values that you see on your screen are related to 115 increment in a 24-hour period. So it is always good to rather look at a pipe or a node or a reservoir or a pump station over in a graph where you can get to see the full 24-hour event taking place. So here you can see at about midday the reservoir gets quite low, and then I've got a switch on the valve to start pumping water or start bringing water into the reservoir. This could be a switch if it's a bulk line that you're bringing the water from, or if it's a borehole or a pump station, it could be a control switch on that. So in this case, the reservoir isn't running out of water. It is getting to 1 meter deep, and then the switch is turning on the valve. This could be a problem if we're now going to bring in hydrants. We might need to switch it on earlier. So just take into mind that you need to actually cater for your reservoir when you've added your fire hydrants. Okay, so what I'm going to do, because we're dealing with liters per minute, I'm going to zoom in over here, and you can see currently I've got one of the pipes switched on, or displaying the category of pipe that this pipe is. So I'm just going to go over to my display settings. I'm going to go over to pipes, and for now we can actually just remove all of this, and I would like to show the flow in liters per minute. So I'll put there liters per min and say OK. And we can see that we've got 3 decimal places, so I'm probably not going to want to see all 3 decimal places, so I'll just change that to 0.1. and here we can see the liters per minute. Probably just give it a space there. That looks a lot better. Great. Remember, the value that you see here is just one of the 15-minute increments in 24 hours. So you need to be able to select the pipe and go and look at it over a 24-hour period. So we can go and look at the graph of this pipe, and we can see that our flow in this case is liters per second, but you can see the highest flow rate is around 4 o'clock in the afternoon. So let's go and have a look at what is that flow rate at 4 in the afternoon with liters per minute as our idea. So we'll go over to our water. We make sure that we're in the results tab, and we can expand our time simulation and go across to 4 o'clock. You'll notice once I've clicked on this, the value will change. So there you can see it's 482 liters per minute that is flowing in that pipe at 4 o'clock. So why I've brought you to this example and is because the maximum flow during a time simulation is the flow rate plus the fire hydrant's flows that's going to take place during the simulation or the fire flow analysis. Great. I'm gonna you can pin this. It's always good to remind to keep it open and to use it when using your water analysis. One other item to point out is when you are running your analysis and you happen to have the apply seasonal peak factor ticked on, which we won't do at this stage, it's another whole WebEx for another day. Just keep in mind that you need to think about the peak flow rate for that if it is ticked on. So if we have a look at the seasonal peak, we'll just change over to this seasonal peak and give it a time and go look at the graph. You'll see that at 9:15 is the highest peak, so we can go and look at 9:15. Let's just press. Now you can see what the peak is if you had the seasonal peak switched on. I'll close this and I'll go back to our 4 o'clock in the afternoon. I'm now going to look at the analysis of the fire hydrants. We will look at the placement of the fire hydrants a little bit later in this WebEx in more detail, so let's just quickly concentrate more on the analysis of them. So if we just zoom out, I'm just going to put 2 hydrants on this line along here. So the first step would be to go to your settings and go to your hydrant defaults. This is to enable to know which hydrants you're going to be placing when you put them into the drawing graphically. So you can choose your fire risk category, that is the high risk, moderate, and the 3 types of low risk. You can also choose your nominal diameter of your fire hydrants and the height above the natural ground if it is sticking out of the ground. You can also choose your fire risk categories again, which we've covered a little bit earlier, and I'm going to use the low risk to start off with, where the simultaneous active hydrants is 1 at a time. And then afterwards we can look at the high risk, where we're having all of the hydrants within the radius of 270 meters on at the same time. So I'll go to close and I'm going to change this to low risk, and we can press OK. I can then go to graphical and I can go to draw hydrant, and here you can see the radius, which I'm going to explain a little bit later when we do talk about the placement of the hydrants. So I'm just going to place 1 hydrant over here. It's indicated the position is less than 1 meter from node 6. It's going to place the hydrant on the existing node. I'll say OK. And I'm going to place a hydrant on this corner over here. With those two, I'm going to press the escape key, and I'm going to run the fire flow analysis so we can have a look at the results. We go to Analyze and we go Fire Flow Analysis. We can then press Start and check our messages. We don't have any issues, and we can press Close. You can see from this table here, or this figure here, that the flow rate has increased. You can also see that you've got your fire flow hydrant 1, hydrant 2, because they have the same flow rates. It's going to be the same result on the incoming pipe to the network, and you've got your summary. If we go to have a look at these results, let's quickly go over to our catalogs and we'll look at the fire risk categories. You can see that the minimum flow rate per hydrant, it was 900 liters per minute, but we also had 900 plus we have the peak flow at the highest point of the day. So let's just quickly recap on that. If we go to our graph, and we can see that at 3:30, 3:15 in the afternoon, we've got our peak flow. So we just go to our latest time simulation, 3:15. Just close that. So you got the 900 plus the 600 gives you the 1500. I'm going to change these over to the high risk category so we can have a look at selecting them. Sometimes you find it's not able to select because the node itself is getting in the way. If we go to the properties, you can see it's connecting on the water node. I find the easiest is just to go to your water node and just to make that not selectable for the meantime, and then I'm able to then select the hydrant itself. You can see I've got it on category low risk group 1, and I'll just change it over to the high risk. I'll just move over to the next hydrant and change that. Don't worry about the size of the diameters, that's all coming in the part where we're going to talk about the placing and spacing of the hydrants itself. Okay, I have them on high risk now, and I'm going to rerun the fire risk analysis. So we'll go over to Analyze, Fire Flow Analysis, and we'll press Start. We'll check for messages. We don't have any warnings at this stage, and we can then zoom in to our hydrants. If we go to our tools catalogs and fire risk categories, we'll see that we need for the high risk 1500 liters per minute. And remember that these hydrants are on, because they're high risk, any hydrants within a radius of 270 will be switched on at the same time, which means that we have the 1500 for each hydrant, plus we've got the peak flow, which was 603.4 liters per minute. I always keep an eye on the flows on the pipes rather than anywhere else when running the fire flow analysis and looking at pipe capacities, probably looking at velocities through the pipe as well. You can't have that to be too fast. You might want to increase the pipe size to cater for the fire flows. One other place to have a look at is if you go to results and we look at the hydrants. Here you can see the hydrants ID. We haven't given them names. We've got the elevation, diameters, the category, and then the flow here is in liters per second, and then we've also got the residual head. Just zoom out a bit, and we need to delete these hydrants and just start afresh. I'm also going to zoom to see the whole site. I'll close these two dialogues for now, and we can probably right click over here and make our node selectable again. Great, with those items set up, I'm going to have a look at the spacing and the placement of our fire hydrants. So the first step that I'm going to do is to go to our settings, hydrant defaults, and for this site I'm going to use the low risk group 1, and I'm going to press OK. I'm also going to go to our display settings. I'm going to go to the hydrants. For the symbol, we're going to use the line pen 14. We're going to use the fold to be pen 1. The symbol size will be 1 in meters, and we're going to use our line width of 0.3. We'll also draw a circle to show the distance for the spacing of the water meter, and we'll do a transparency. We're going to use a color scheme of default, but you can use of groups, fire risk categories, required flow, actual flow, and residual head. So you can have your circles which are displaying the spacing, also have a color category for that. We'll draw it, annotate with the solid pen, and we'll use a text of 2 millimeters. We can also have the text to display the category. For now I'm happy with that. I've ticked on this item, and I'm going to press OK. I'll then go to graphical, draw hydrants, and I can go ahead with placing the hydrants. Now when you place the hydrant, yes, we can put a hydrant here, and yes, it is within the radius to serve this street, but it's not necessarily going to give access to that street along this route. It might be too long. So it's always easier to rather put it at intersections, and intersections that serve the greater community would always be better. I'll place it on this node here, and it will say that it has found a node within 1 meter, and it will place it at that node. I can then see that it will serve these areas as well, and we can probably, it really doesn't matter to have an overlapping service rather than not having a service. So we'll place some hydrants over here as well. You can see if I place this hydrant, we're going to have a lack of service here. So we'll go and place it on all the extremes, and we can go and fill in the gaps later. So I've clicked near, and it's found that there is a node. Would you like to snap to that node, or would I like to split the pipe and insert a new node? So I'm going to rather snap to that node. So it's always, as I say, best to try and do the extremes and go and fill in the gaps later. So here you can see that it will probably be best to have a service over here. As you'd want to be able to, it's quite a long distance away from any other nodes, so probably be best to have a service probably that would serve the greater community than rather putting it over there. Rather have something here. I'm going to place it at this intersection here. It'll serve the community a lot better. So we'll go in here. I don't want it to be in the middle of the intersection, so I'm going to place it somewhere a little bit away from it. And it's going to ask me, do I want to split the existing pipe and insert a new node? I'm going to say yes. And so there it's placed the fire hydrant a little bit away from the intersection, but perfect for that area. Great. You can then run your fire flow analysis, check for any warnings, and you can then also review your flow rates coming into the town or anywhere along the route, or velocities, to make sure that you're happy. Remember to click on each one if you're running different types of risk categories. You can also have a look at your results and look at your hydrants. You can see your flow rates and your residual head. These flow rates are in liters per second. Just want to zoom in over here, and before we move over to the reservoir, little tips and tricks that I can show you. If you go to your water operations and you go to your graph, if you want to change the graph for or the flow rate for this graph, you can also go and right click and say show the results for this time, and then your results will update. You can just press the escape key and your results will then reflect for that time of day. Hope that helps. It's a little trick, but both are very important to know about where to find your results. Okay, when it comes to firefighting and the reservoir, earlier we spoke about having enough water for firefighting. We had a look at the graph. You could see that the graph, the water was depleting, and when it reached 1 liter, I switched on the valve to, or had it automatically switch on, that it would start filling up again. This is always dependent on your local guidelines for the area that you're working with. To consult these guidelines and have a look at what the requirements will be. The fire flow analysis is for the hydrants and for the flows in the pipes. But for the storage requirements for the reservoir, you will need to calculate that and make sure that you have enough storage space. So when it comes to the storage, you need to make sure that in some municipalities and some guidelines, the reservoir shouldn't get less than 65% full, and then the valve or the pump should switch on to start filling up the reservoir again. When you're looking at the flows required for firefighting, it's always good to look at your fire risk categories. Here you can see we are dealing with 900 liters per minute, and we should be, our duration will be 2 hours. So our firefighting should be the 900 liters per minute times 60 times 2 for firefighting. It gets a little bit more complex when we're dealing with the high risk and the moderate risk. You'd need to then calculate the amount required for that and make sure that your reservoir is always having that amount available. So in other words, that the switching on of the pumps or the valves opening should take place before the water for firefighting and for maintenance periods does not get depleted. For the new people joining us, this is the way I switch on the water coming into the reservoir. I would first go and have the reservoir showing its ID, and you can then have a flow in source. Bear in mind, this is one of the ways of doing it. The better way to do it is to have a flow coming in. Just see if this water node is selectable. So here you can see I've got a 2.5 preset pressure. This would need to be given to you by the local supplier of the water. If it's variable, you can bring in a variable flow coming into your network. That would be preferable if you have that data. And then the valve switch I've got set that at on-off level for reservoir ID number 1. The flow should be fully open at 1 when it reaches 1 meter deep, and fully close when it gets to 3 meters. Some people say that should be 2.9 because you don't want to go right to the roof of the reservoir, and also the fully open should actually be when it's 65% full. So I'm going to make that when it gets to 2 meters. You can then press OK, but then you would need to rerun your time simulation and press start, check for messages, close that, and you can relook at your graph for the reservoir. Here you can see it gets to 2 meters and it will start filling up again and start depleting again. So that ensures that at least 60% of the reservoir is reserved for maintenance and for firefighting. But please make sure that that is just a level. Make sure that there is actually a quantity in the reservoir to hold that amount of water required. So to do that, you'd need to go to your data and you'd need to look at your actual capacity in the reservoir. Okay, that's just a quick step for the new people that are joining us. But that covers firefighting at this stage. If there's any questions, please feel free to email us at helpdesk@civildesigner.com. And also, one last thing is to go to your help and go to about, and then just press the check version button to make sure that you're using the latest version of Civil Designer. Please do this check for us. It helps greatly in ensuring that everybody is using the latest. Anyway, that's all from me for today. I hope you have learned something. Have a great day further. Back to you, Charles.
Thank you very much, Chris. That was great. I've learned a few things today. And thank you very much to all of you who attended today's webinar. Please remember, if you would like any further information or assistance with regards to the contents of Chris's presentation today, or if you would like to request future webinar topics, please use the email address listed on your screens right now. Once again, thank you very much for your time today. Have a great afternoon, weekend, and goodbye for now.